Hello, this is problem 3.5, and I will show you how to do this problem in two different ways. But before we start, we need to review few rules. So remember, when we write square root or any root, we're using the word radical, and radical sign looks something like this. If we're talking about square root, we assume that if we don't see anything here, it should be 2. Now, a couple of definitions. So this number right here that might be on there, let's call that number index. That's what we call that. It's usually a small number that tells you the degree of the radical. And then you might have x or whatever variable there, and then you have your exponent there. And let me use different color here. So you have exponent here. Exponent. So if we have a square root, we don't write the index, but we assume it's 2. Now, very important rule is that in order to rewrite radicals, you can use exponents. So this expression right here could be rewritten as x to the power of exponent divided by index. It is a very powerful tool, because that allows you to take most complicated problems involving square roots or other roots and turn them into exponent problems, and then all you have to do is add or subtract exponents that are fractions. So for example, if you had cubic root of x to the 5th, you're allowed to write that as x to the power of 5/3. And then you deal with that as you would with any other exponents. That is one method. Another method is that if you have a multiple roots, then for example, if you have 3rd root and then 4th root and then x, you can just multiply these two, 3 times 4, and say that's a 12th root of x. All right, so let's get to the problem. Sorry about this. So in this problem, first let's do it using exponents. So if we use the exponents, I'm going to ignore everything that's under this root. So everything that's in yellow, we know that there's a 4th root to it. So what I'm going to do is pretend like this thing in yellow has a power, is one own thing and has power of 1. So therefore, I could rewrite that as something to the 1/4. Next, I could look at here and ignore everything that's yellow and simply rewrite as power of 1/12, because now everything here is one thing, so it has exponent of 1, and then index is 12. Next, I could rewrite this root here as a power of 1/3, because it's a 3rd root. And finally, last one is a square root, so we don't see an index, but that means the index is 2. So that would be just power of 1/2. And then after that, I can go inside each one of those and simplify further. So now I look at first part. Using our rules of exponents, we can rewrite this as a to the 5/6. This here would be a to the 3 divided by, again, index is 2. If we don't see it, then a to the 9/8. And finally, a to the 1/12. So from here on, we just have power to a power, so we just multiply across, and we have a to the 5/24 times a to the power of 3/24 Now we have a power of 9 times 1 is 9 over 8 times 3 is 24. So 9 over 24. And eventually we have 1 over 24. So now we have a bunch of same bases with different exponents. So that means we just need to add all of them. So it's going to be a to the power of 5 over 24 plus 3 over 24 plus 9 over 24 plus 1 over 24. It's the same denominator, so it's going to be 24 in the bottom, and then we just, up top we have 5 plus 3 plus 9 plus 1. 9 plus 1 is 10, 5 plus 3 is 18. So it's a to the power of 18 over 24. We could simplify that. We could divide by 6. So if we divide by 6, 18 divided by 6 is 3. 24 divided by 6 is 4. So we get a to the 3/4. And if we want to rewrite that as using radicals, we put a here. The 3 is the exponent, so it goes here, and 4 is the index. So it looks like that. Well, now let me show you the same problem, but done in a different approach, different way, and probably much faster. So different approach. If we have multiple roots, all we need to do is look at the indices. So we have 4 and 6. So that's 4 times 6 is 24. So we can rewrite that as 24th root of a to the 5th times. Now let's look here. Index is 12. We don't have index here. That means it's 2. So we have also 12 times 2 equals 24. So that's 24th root of a to the 3rd. The next one is 3 times 8 again. So it's index of 24. So 24th root of a to the 9th. And finally you have, again, no index. That means it's 2. 2 times 12 is 24. So that's 24th root of a. Since we have the same radical, same index, we could just write that it's a 24 root of, and then multiply a to the 5th times a to the 3rd times a to the 9th times a to the 1st. So it's 24th root of, and then we have same basis here, a, and it's all multiplication, so all we need to do is add exponents. So that would be a to the power of 5 plus 3 plus 9 plus 1. 5 plus 3 is 8. 8 plus 9 is 17, plus 1 is 18. So that'd be 24th root of a to the power of 18. And we could simplify that because we could divide both of these. We could divide both by 6. The reason we could divide them is because we could also rewrite this as an exponent as a to the 18 over 24, and then we could reduce this fraction. So that would be 24 divided by 6 is just 4, and then 18 divided by 6 is 3. So this would be our answer. So that's just another way how to do the same problem.